Here I have this new release, the latest release of Mira, and it was, by the way, a very nice demo with the false money banknotes, Matthias. So let me just maybe show you some other example. As Matthias told, we can work directly with the TIFF images or the NV images. I will also choose the TIFF format, and let's add some images to the project. And these are some images of plant leaves that Matthias captured the other day. We have a couple of cubes. We should, on the right side in the spectral plot, we can play a bit with the RGB preview, so to get a nice, more realistic image. So you can see that we have some leaves. Some of them are clearly more dry than others. Now the first step in the analysis would be for us often to do the classifier. We have seen it already from Matthias. So let's just quickly here segment the leaves from the background. So I can create a new class and paint some examples of background, make a leaf class, just label more of them and build a model. So we want to segment the leaves. Now in Mira we have tools to basically help us to do nice labeling. So for example, this show unknown functionality lets me to highlight parts that are not yet represented well. So for example, around the leaves, I should do better job with labeling. So I can zoom in, select, and just do some nicer work here. And I can always validate how I'm doing on other images. Like here, for example, you see that there's quite a bit of a difference. So I should improve here, and I should improve here. Okay, here we are also missing the leaf. I'm just retraining the model that was already found. So normally I would click the retrain button instead of model search button to get a quick update. And I did not click because I was just using a shortcut. There's lots of shortcuts that we use for common tasks to quickly execute the function. So you see that I have quite a good classifier on for the leaves. Now it's possible to select to segment the objects that we often want to work on the object level. So we can highlight which class is for us interesting. It's the leaf. It's a foreground class, and we can get a object label image. So here for every object that is spatially connected, we get a different color. At the bottom of the screen, you see which object it is. So this one, for example, is object number 3. And I can also let the software to display the list of objects. So for example, object number 3. Here you can see also the centroid. You can see the size in pixels, the bounding box, and also the class, because a part of object labels, we also can perform object classification. Here it is just a single material per object, so it's basically just what we labeled, but we can have multiple classes, and then we could have objects of different classes also detected. So this can be basically used for object sorting or object detection solution. Now what I would like to show you is the next functionality, and that is the visualization. We will return back to objects in a short moment. The visualization was requested a lot by a number of customers, and that basically allows us to compute different common equations or indices on the image. And so here I have a special visualization panel on the top, and you see that I position it above the spectral plot because here I actually have the range of wavelengths that I can interactively move, and I directly can see the image that is showing the integrated value per pixel in this set of wavelengths, which I can adjust as I like. So you see that we define these parameters in nanometers on the wavelength sense, but in the end we are mapping it to the really existing bands in the sensor. So you can also get to a situation that you don't have any bands left, and then it would become just red as invalid. So this one would be just basically a single band, but we may be interested in other setups, like, for example, division of 2 bands, and we can be interested here in highlighting this difference that will allow us to basically see how healthy the leaf is. And if we move around the image at the bottom, the status bar, you can actually see the floating point value. So this is not only a rendering of that index, but we also have access to the floating point data. So you can see that a leaf that is nicely green is having very high value, and this leaf that is very dry is lower value. Now, what we are getting here is auto-scaling of the values in the entire image, but often we are interested actually in dealing with objects. So if you already have a classifier and you set some classes as the foreground, you get the visualization only for the foreground classes. And also the auto-scaling of the values is happening only for the foreground, so that helps you to really focus on the objects of interest. We can select different color maps, and we can also, for example, give to background different pixels so that we can really see the difference between very dry and really background pixels and different leaf. So this visualization is then applicable to any image, so you can explore more. As you can see now, on every image, the maximum and minimum value is actually changing because I have the auto scaling on. That is not, of course, too practical. It's if you adjust the range a bit, the auto scaling goes off, and then we have the same range. So actually, it doesn't matter, but we will get the absolute value in this range and not jumping, basically. You can see that some parts of the image became light blue. That is because the pixels in these areas have a value above the top of my visualization range. And in the same way, if we change here the minimum, you get pixels highlighted that are below. So that allows us to understand how far we can basically go to have a good range of the value. So what I could do with this setup, for example, is that I can see here some confirmation which leaves are more healthy than others, and I can go back to the labeling and actually create a new class, for example, called dry or whatever. And I would like to label the leaves that are very black to this new category. So I could, of course, make new label, but I can also now in Mira just assign any label region to a given class. So that's much faster way to label. For example, here I can simply label this part, and also this one is probably not so nice. Another thing that you can actually do now in Mira is that you can have a category that you simply call like ignore, and you can exclude it from training. And then if you are not sure, you can quickly assign label strokes to it and basically make a very quick what if analysis. If I label this data, will that affect my my modeling? So we can do that, for example, over here. And on these examples, I'm not really sure. Maybe we should do like this. Okay, so if I now rebuild my model, I may get a bit different picture. I could improve that classification, but in the end, we are basically now looking at the model that is trying to decide if the leaf has a specific type of health condition or not. Of course, you know much more than me on how does that really work, but that's the idea, that people can basically use the index or a specific equation from spectral data to also help in guiding the modeling, and then in the end get the modeling per object, let's say. So that is one type of functionality. What you could then do is, if we play with this a bit more, and if we can export basically, or we can get per object information, whether the leaf, I mean, what is the content inside the leaf, how many pixels are labeled as dry or ill, and how many pixels are labeled as healthy. So that can really help you to do classification per object, but by content. So this is the first example, and then the second example I wanted to show you is on regression, where is also a lot of new functionality coming, and that is a different data set created by Matthias, and that is on example with black tea and green tea, if I'm correct. So we have here different vials that contain some mixtures of tea. And what we want to do is we want to actually not just classify, but we would like to estimate the concentration or the mixing proportion of different materials. And in Mira, you always start from a classification task first. So we basically define, let's say, the background, and we define the tea or whatever as a product classes, and build a model. Maybe we are also interested in having a third class where we mask these vials. And because we don't really care about it, we only care about the samples. We flag them as a foreground, so we can actually segment the objects, and that's the starting point for the regression analysis. So now we can build a classifier, that's nice, but if we want to do a regression modeling, we should do something extra, and that extra is annotating actually what is the numerical property that we want to estimate. So we can add point annotations now, and we know that in this vial was just a 0% of the black tea, and in the one next to it was 1/3, so 33%. Here was 50, here was 2/3, and here was the full 100%. So now I actually annotated these objects. These point annotations should be really on top of objects, because then spectra of the objects are used for the regression analysis. I'll just put a regression panel on this side, and we can create a regression data set that actually shows me here that I have 5 annotations, and I also in the end have 5 objects represented for regression modeling, and I can train a model. And if we stretch a bit this plot, maybe it's too small for you to see, but I can see here in the regression plot on the horizontal axis is the true value that I annotated, and on the vertical axis is the estimate. And I only have 5 points, and they are showing here on the next to the diagonal. I could also label some other image, like here. We just provide more examples. And I can flag that as a testing image. And if I update the data set, you will see that I have 5 objects for training and 5 for testing. And if I retrain the model, I will also start seeing green points next to it. And in the legend, you see the R-square and Q-square statistics. So that's a fit of the training data, which is very nice, but much more important fit of the test unseen data, which we have like 0.95 or 96, which is not so bad. In the output window, you can also see the cross-validation error that is actually having the units of your measurements, which is more interesting than this unitless number. And now basically I built a very crude regression model that I can apply to any image. So I can just say on any new scan, if I get a new scan, I can say apply to the image. What happens is that my classification is applied, my objects are found, and for each object that is big enough, you actually get the single value per object. And in the output window, you would see you would actually see that for each object, we again have the centroid size, bounding box, and now also the regression output. So in this way, we can quickly see what happens in the vial, what is the value. And we can also actually now run the regression on the per pixel level. So you can see the distribution of that regression model output in the image. And then we can also basically understand the inhomogeneities or anything that is happening in these files. So this is a very crude example. It's very important to do a proper validation, especially with regression modeling. So that's why we put a lot of attention to the workflow where people can see unseen objects. Once you have the regression modeling, you can select a bunch of images and simply go to export and export the regression results. And you can get an Excel file with the outputs. So here is Excel file that we created. And now we get basically a table for each image. We have the status, if it was training or test image, all the information about the bounding boxes, if there is a true regression value available, and the output. So you can actually continue your analysis from the Excel side and just act on it. So that's basically the idea here, that we are interested in more workflows that people can really do until the end and basically do their own research based on some intelligent processing of the spectral cubes.